Hello everybody, welcome back. Let's talk about composition of functions, and this time I've got an interesting question to test your knowledge. After reading through the section, let's see if you can answer this question. Let f of x be 2x minus 3 and g of x equal 1 over x plus 1. The question is, what value of x must be excluded from the domain of f so that g of f of x can always be evaluated? So at this point, I'm going to ask you to pause this or wait and come back and try this out yourself. What value do we have to exclude? Okay, well, now that you've had a little bit of time to think about this one and hopefully have tried to work out something, let's see if we can at least get you on the right foot. G of f of x, remember we're taking a composition of the functions g of f of x, which means that everywhere we have the function g of x, we're going to replace x with the function f of x. So if we were to rewrite it, we would say 1 divided by 2x minus 3 in place of x plus 1. Well, now if you simplify that expression, we're going to get 1 divided by 2x minus 3 plus 1, which is the same thing as saying 2x minus 2. So now we're asking, well, what value of x must be excluded from the domain of f so that g of x can always be evaluated? Well, in essence, what we're trying to find out is what value of x will make this quantity equal to 0. So the domain of f of x is all real numbers. However, we can't include all real numbers because clearly substituting in a value of x equals 1 down here is going to result in a 0 denominator, right? So we want to find out, well, what value then can we not put in? Well, we're going to find out by finding the value of 2x minus 3 that does not equal negative 1. Why? Because we want to find out what will make 2x minus 3 equal to negative 1. So when we check this out, we add 3 to both sides, plus 3, plus 3. We find that 2x could not equal, get my pen working here, 2x will not be equal to positive 2, and dividing both sides by 2, we find that x cannot equal 1. So in other words, we must exclude 1. Exclude x equals 1 from the domain of f of x. Because what that will do is that will give us 1 in the denominator, negative 1 in the denominator for the quantity x plus 1, giving us a 0 down there. In other words, when we take the composition of the two functions, the denominator will be 0. Okay, so far so good. Let's go through one more example right here. And let's ask this time, we're going to use a composition of functions to evaluate the expression f of g of 2. So let's work that out. What does f of g of negative 2 mean? Does it mean multiply the composition f of g times negative 2? Well, the answer is no. In this case, this notation means let's evaluate f of g of negative 2, which means we need to evaluate g of negative 2 and substitute that into f of x. But we're going to actually take it from the standpoint of finding the composition f of g of x first and evaluate this quantity. Evaluate, let's see if I can spell evaluate here. Evaluate f of g of x at x equals negative 2, which is the meaning of this particular question. So f of g of x, what is that? Well, f of x is x plus 3, and g of x is 2x squared minus 9. So anywhere we see x in the expression f of x, we're going to replace it with the expression from g of x, 2x squared minus 9. So we'll have 2x squared minus 9 plus 3, which we'll rewrite as 2x squared minus 6. And we're going to evaluate that now at negative 2. So we're going to find f of g of negative 2 to be equal to 2 times negative 2 quantity squared minus 6. That is to say 8 minus 6, or positive 2. Okay, one more video to go.